This is a Zima board from Icewheel Technology. They're calling it the world's first hackable single-board server. I'm calling it the answer to the question, what would happen if your server had an affair with the Raspberry Pi? Welcome back to the ProTech Show. Disclosure bit first, I didn't buy this, they sent it to me. But there were no conditions attached, no money changed hands, it was speculation on their part, this video is not sponsored. This video is a review, and I do not accept payment for reviews. Stop asking, you know who you are. So what is a Zima board? Well, it's a computer. A small, passively cooled computer that can be used by itself or as the brain for a DIY project. What makes this interesting is they haven't gone down the route of an ARM-based platform like the Raspberry Pi and its various clones. Under this heatsink is a full-fat quad-core Intel x86 processor. It began as a Kickstarter, but having smashed its funding target, it is now in full production. We'll take a look at its features in just a moment, but here's why I found this interesting. I have always liked the idea of these little low-powered devices for DIY projects, but they don't seem to like me. The Raspberry Pi is the one everyone knows about, but I already have a home lab, so deploying little bits of additional hardware all over the place instead of just virtualizing or containerizing it doesn't make a whole lot of financial or practical sense to me. There are situations where it would be really useful to use dedicated hardware for an application, but if you draw a Venn diagram of those applications and applications that can run in a Raspberry Pi, it's just two circles for me. Because this is an x86 platform, there's a lot more we can do with it. It could serve as a controller for a storage appliance using TrueNAS. You could use it as a firewall by installing OpenSense or pfSense, or even something a bit more commercially focused like Sophos on it. It can run Windows. I could turn this into a Veeam backup server for my home lab. Perhaps more interestingly, Veeam has an option for immutable storage to provide protection against ransomware. Veeam itself runs on Windows, but the hardened repository that provides that immutability requires a physically separate x86 Linux server. This could be that. And yes, all of the usual home lab things you might do with a Raspberry Pi apply here as well. Home automation with OpenHub or Home Assistant, file sharing with Nextcloud or OwnCloud, a media server with Plex or Jellyfin, and so on. Let me know in the comments if there's something specific you'd like to see me do with this. Right now, I'm going to use it to edit 4K video, because that's an obvious thing to do, right? Out of the box it comes running a version of Linux called Casa OS. This is Icewheel's own creation based on a Debian 11 desktop. Its main party trick is a user-friendly web interface for managing the device. This lets you deploy common apps like Nextcloud or Jellyfin in containerized form from an app store of sorts. Basically, it's a home lab in a box, and although it looks pretty, I didn't spend a lot of time with it because I already have a home lab. I wanted to know how else I can use the Zima board. Clearly the onboard hardware is going to be limited, so let's have a look at what we get and how we can extend it. This particular model comes with a Celeron N3450 and 8 gigs of RAM. Obviously when I said Intel, it's not running an i9 in a passively cooled package like this. This is the higher end option of the three models currently offered. I'll put the specs and prices of all of them up here. In terms of connectivity, we have two USB 3 ports, 2 gigabit Ethernet, one mini DisplayPort 1.2, and a power jack. Turning it around, we find two SATA 3 ports and a connector to power your SATA hard drives. The Zima board comes as standard with a cable to connect and power a single SATA drive. However, they also sell this optional Y cable that will let you attach two SATA drives and share the onboard power between them. This Y cable will only work for 2.5-inch drives though. If you want to power more than one 3.5-inch drive, you'll need an external power supply. There is also onboard eMMC storage. The top two models have 32GB, whereas the low-end model only has 16. Personally, I would like to have seen 64 gigs on the high-end model. One of the advantages of an x86 platform like this is its ability to run Windows, but 32 gigs is barely enough to install Windows, and by the time you've installed drivers and updates, you'll be out of space for any apps. In fairness, they describe it as a single board server, not a desktop, and 32 gigs is enough to run most server operating systems on board using external storage for your data. A quick check of the servers currently running in my home lab shows that Windows servers with a desktop won't fit. Windows servers without a desktop, previously called Server Core, will fit okay in the 32 gig versions. None of my Linux servers have a desktop installed, and all of them would fit quite nicely on the 16GB model, so this is only really an issue for the Windows desktop. But it would be nice to be able to run that more effectively from the onboard storage. 32GB won't go far once you start adding data though. There are 2 SATA ports to add drives, but what if you need more? Turning around to the side of the Zima board, we see its most interesting feature, a PCI Express Gen 2x4 slot. Need more storage? Now it has 2 NVMe slots and an extra SATA port. Still not enough, the Zima board shop has a 5-port SATA card which takes your total up to 7 additional hard drives. That's a lot of storage. Of course, at this point you'll definitely need an external power supply, and your neat little single board server will have turned into a spaghetti mess of cables. This slot provides a lot of potential for expandability. Want to use this as a firewall? Well, it has 2GB Ethernet ports. There's your WAN, there's your LAN. Need a DMZ? You could use VLANs, but what if you need more physical ports? What if you need more than a gigabit per second? Slap in 4 more 2.5GB ports via PCI Express and there you go. There is one small detail I really appreciate about this, and it may not be immediately obvious. Take a closer look at the PCI Express port and you'll see that there's a bit missing. This isn't a manufacturing defect, they've deliberately left this end open so you can do stuff like this. PCI Express Gen 3x16 card, PCI Express Gen 2x4 slot. Thanks to that little cutout, this actually fits. And it actually works. Let me get this powered up here. This is a 10-year-old card because, well, it's all I have spare. Part of me really wants to see how ridiculous this would look perched on top of a current high-end GPU though. Obviously the PCI Express slot would be a bottleneck for bandwidth intensive operations, but I like that the designers gave us the option to do this. A quick note about Windows 11 while it's booting up here. Windows 10 is fully supported, but Windows 11 falls into that weird middle ground where it will install just fine without complaining to you about unsupported hardware, but it then won't install future feature packs unless you mess about with the registry. The reason for this is although the Zima board comes with Secure Boot and a TPM, although they're disabled in the BIOS by default, its processor is quite dated and it isn't officially supported by Windows 11. I'll link a video in the description that details those registry changes that you need to make for unsupported hardware, but there's no two ways about this. The Celeron N3450 is an old processor that debuted towards the back end of 2016. I mean, it does the job and it supports virtualization, but it is a little disappointing that you can't buy a model that is actually supported by Windows 11. And I wonder if a processor fabricated using a newer process node might have been more power efficient, which is clearly one of the Zima board's design goals. I assume it would have pushed the price up a bit, so it seems like the obvious thing to do is test the performance of this unit and see how that compares to the amount of power it's consuming. I've mentioned the Raspberry Pi in this video because of the form factor, but in reality that's not the competition here. Think of the potential use cases I've been listing off. pfSense, TrueNAS, Veeam, Windows, Sophos XG, none of these will run on a Raspberry Pi. The real competition for this, I think, is an old computer. A lot of us techies will have old computers that could be redeployed in a home lab, so with that in mind, does the Zima board still make sense? To try and answer that, I'm going to benchmark it against my desktop and my laptop. The laptop's fairly old and its Intel i5-7200U was released about the same time as the Zima board Celeron. They are both mobile processors designed for power efficiency, so that should be an interesting comparison. I'm going to run Cinebench R23 to put it under load. To be clear, I'm expecting the score to be terrible. It's a passively cooled Celeron, this is not a realistic use case for it. But what I'm really interested in is how much power it consumes when it's under load, because that tells me how much it'll cost to run. To no one's surprise, the Zima board scored terribly in Cinebench, and the desktop wiped the floor with both it and my aging laptop in terms of raw performance. When we look at idle power consumption, the Zima board and laptop both used a fraction of the desktops. This makes sense, seeing as the Zima board needs to run without active cooling, and the laptop is intended to run from a battery. Power consumption under load shows a similar pattern to the Cinebench score, although in this case, lower is better. The desktop ran away from the others, exceeding 200 watts. The laptop hovered around 25 watts, and the Zima board never reached double figures. To create a crude sort of efficiency score, I've divided the Cinebench score by the watts consumed, and we end up with this. As expected, the desktop was the least energy efficient, but the real competition is between the Zima board and the laptop, and the Zima board came out on top. I still can't help but wonder how a more modern architecture would have performed, but this is a good result. It's not enough of an efficiency win over the laptop that I could say the difference in electricity would pay for the Zima board, even if taken over a 5-year lifespan. On the other hand though, my laptop is not going to last another 5 years. It's starting to fall apart as it is, the Zima board is brand new by comparison, and I couldn't buy a laptop for the same price as the Zima board. The Zima board is also much smaller and completely silent. So if you have an application that doesn't need a lot of processing power, I think this is a nice option. But how does it handle video editing? Obviously it won't, not natively. I do have an idea that I've been wanting to try out though, and this seems like just the right device for it. I have a desktop upstairs that I do my editing on. It is a Ryzen 3700X and a Radeon 5700 XT. It's enough to edit 4K video and play games respectively at 1440p. But it's upstairs, and I would quite like to harness its gaming ability on my sofa, and its workstation capabilities downstairs, and perhaps when I'm away from home. Editing or gaming with a laptop keyboard and trackpad sucks. What I need is a cheap and portable device to use as a thin client. The device is only part of the equation though. I also need some remote access software that can handle a decent frame rate with low latency. Video editing is different from general office work. If I'm trying to line up audio with video frames, I can't be having lag. The software I'm going to pair with this is Parsec. It's remote access software that was designed with low latency in mind for game streaming, and allegedly this makes it good for video post-production as well. Once upon a time you could run it in a Raspberry Pi, but no longer, so my sensible reason for putting it on a Zima board is remote video editing, and my less sensible option is to plug it into my TV and play games. Before we can do that, we need to upgrade the Zima board with Wi-Fi. Happily, I have a little Wi-Fi 6 PCI Express card that Icewheel sent along with it. This does highlight a slight issue with the Zima board's design though. With the standard PCI bracket attached, the display port is blocked off. Fine if you're running this as a headless server I guess, but if you want to plug it into a monitor or a TV, you'll need to remove the bracket. For the other cards, this wasn't an issue, but for the Wi-Fi card, I have nowhere to attach the antenna, and I'm a bit worried about these wires. I also found that with the PCI Express card hanging off the side, a bit of extra support was necessary to prevent disconnections. This product is going to appeal to tinkerers, so I'm sure some of you could 3D print a mount or something, but I'm just going to have to balance this next to it for the time being. I've got myself set up here. The desktop's connected by Gigabit Ethernet, and the Zima board is connected to the same LAN using Wi-Fi 6 at about a gigabit. This should be a pretty ideal scenario for me to work downstairs. Now let me show you why I chose Parsec. I'll start by comparing it to the venerable VNC. Honestly, I don't know why people keep recommending it, as there are much better performing options these days. I have memories of doing remote support back in the day for customers with bad internet connections using VNC. It was rough. Even over a gigabit LAN, it's not cut out for this use case. I'm playing back a video at 1080p and it's very choppy. It also doesn't support audio. Frankly, it's not built for this, but I wanted to start here before it got spammed in the comments. The more obvious thing to use in Windows is the remote desktop that's built in with the Pro Edition and up. This is a lot better. RDP is pretty damn good, and for general office work it's absolutely good enough. The video isn't quite as smooth as I'd like it to be for this though, so let's try Parsec. I'm not sure how well this will be picked up by the time it's gone through my capture card on YouTube, but there is a tangible improvement here. Remote desktop had tiny but frequent little stutters. Not massive, like I say, you wouldn't notice this using Microsoft Office. But working with video, it's enough to be annoying, and I'm sure it would be for gaming as well. I wouldn't say Parsec is indistinguishable from the local experience if you look at it very closely, but it is close enough that using it for a while I genuinely forgot I was on a remote computer. It streams either H.264 or H.265 depending on the capabilities of the devices on each end. I'm happy to report that H.265 is working fine in the Zima board, and this is small enough to chuck in my bag and go. As long as I don't need wireless, that is. If I chuck it in with a PCI card sticking out, it'll probably snap. Which brings me to a few downsides. I've mentioned the onboard storage being a bit limited and the CPU being quite old. Something else I'd like to see in a future revision is a couple more USB ports. 2 is enough to use this as a headless server, but I've installed a few different operating systems whilst playing with this, and here's the problem with 2 USB ports. One for the keyboard, one for the mouse. Where do I plug in the install drive? I mean, okay, USB hubs are cheap, but it would be nice if I hadn't had to dig one out, and I've been using this a lot. If I'm being picky, I would have preferred Intel networking over Realtek. Intel has a better reputation for reliability and performance, although personally I haven't really had problems with either. I have had the odd occasion in the past where a Realtek NIC wasn't supported though. That'll have been something obscure like a HomeLab VMware build and won't apply to 99% of people, but the obscure scenario where it does is also probably the sort of obscure kind of scenario where someone might try to use a hackable single board server, which is why I mention it as a consideration. In terms of repairability, the only part that's user serviceable is the BIOS battery. You can get at that by removing the screws from the protective acrylic layers at the back in case you mess up and need to reset your BIOS. Everything else is soldered in place, but it says single board server. It's kind of in the name there. Is it worth buying? For the right person, yes. The right person, I think, is a tinkerer. If you consider any one specific use case, there's probably a better option somewhere for that specific use. Plug in a few drives and you have a NAS. But if you're setting out specifically to build a NAS, you'd probably be better served by a chassis with room for hot pluggable disks. Add some more network ports and you can build a comprehensive firewall router combo. But there are pre-built devices with lots of NICs already included without hanging them off an external PCI Express card. Where this shines is in its size, power consumption, and its adaptability. Today it can be a NAS, and tomorrow it can be a firewall. For example, I'm going to plug it into my TV next, and after that, I think I'm going to build an immutable backup repository with it. Maybe I'll stick Kali Linux on it and make some security related videos. That's all part of the fun with it, and that was my overall impression. If you're into home labbing, this is a fun little gizmo with quite a few practical uses. Let me know what you think in the comments and let me know what you'd like to see me do with it. I'll put a link in the description. I don't get any kickback, but if you're into home labbing, feel free to check it out. Check out one of these videos while you're at it as well, and give the like button a bit of love. See you next time.